Greetings, everybody, and welcome back to MathZone African Motives. So, our focus today is Physical Sciences Grade 10. And so, we're going to get into a new topic today. Okay. Um, so, we're going to get into motion in one dimension. So, our next topic here is motion in one dimension. Motion in one dimension. Okay. Okay. So, we can start by defining what is motion in one dimension. Okay. So we're saying this is motion. This is motion where an object motion where an object motion where an object is constrained to move back and forth along a line. Okay, so that's the description of what. So it is the movement of objects, okay, along a line. So the objects here move in a straight line. See? Um, so let's begin with speed and velocity. Okay, we're going to look at speed and velocity. Speed and velocity first. Okay, speed and velocity. Speed and okay. Now we can. So let us begin. Okay, now here. So the difference between the two, okay? Speed is a scalar is a scalar quantity. Okay. Speed is a scalar quantity. It's a scalar quantity. So magnitude only. Okay. This means that it doesn't have direction. So magnitude only. Speed is a scalar quantity. Whereas velocity is a vector quantity. So velocity is a vector quantity. Oh, sorry. So this over here, the spelling is wrong. So a vector quantity, meaning it has magnitude and direction. Velocity is a vector quantity. So, okay. So let's write down a few definitions here, okay? So this is the big difference here is that speed is a scalar quantity and vector is a velocity is a vector quantity. So let's look at average speed. Average speed. Um, so average speed, what? The definition here is average speed again, we should know the definitions, people, okay? It's not just about the formula, but the definition is also important, okay? So average speed is the distance, d, is the distance d, okay, traveled, traveled divided by the time divided by the time delta t taken. For the journey, okay? divided by the time taken for the journey. Okay, so the average speed here. So the formula is like this. We say average speed is equal to d over delta t. Okay, so the distance here should be in meters and the time should be in seconds. So again, unit conversion is important, okay? And the average speed, the unit is what? Meters per second, which is denoted this way, okay? So again, we can start here. So this is this over here is the average speed. So what we, in terms of symbols, okay, we're going to say V average equals to D and then delta T. See? And then let's talk about, so again, you should know how to convert all the units, meters, seconds, and meters per second. It should be this way before we start calculating. So we don't use centimeters or minutes or kilometers per hour, okay? So we should know how to convert these things, okay? Like example, if you're given kilometers here for the distance, you should know how to convert. So, okay. Now let's go to average velocity. Average velocity So now average velocity, we start with the definition, okay? Average velocity average velocity is the change in position, is the change in position. Again, you see the difference here. It's not the distance, it's the change in position, okay? You can see the difference already. So we talk about a change in position when we talk about velocity, okay? Whereas previously is the distance, okay? What is the distance? D. You see, average speed is the distance traveled divided by the time. So for speed, we talk about distance. For velocity, we talk about a change in position, okay? You should notice the difference, okay? Um, is the change in position, delta x, okay, of a body, Look. Of a body divided by the time okay. So the time is the same, because the time is a scalar quantity. So it's delta t here, it's delta t divided by the time t. It took for the displacement to occur. For the displacement to occur. Okay. Now, in terms of the formula, we're going to say average velocity average velocity gonna be change in position divided by change in time, or you can say the time taken. Change in time. And again here, it should be in meters. The time should be in seconds. And the velocity here should be in what? Meters per second, okay? And then in terms of symbols, what do we say? We say V average, AV, and then denoted by a vector, okay? Equals to change in position is delta x, and then change in time, delta t, the time taken for the displacement to occur, okay? So the average velocity and the average speed, okay? One is a vector, the other one is a scalar. So you see the difference here in what? In notation. The small arrow on top of the V tells you that that thing is a vector, okay? For this one, there is no arrow here. So it's not a vector, it's a scalar quantity. See? So very important, okay? Very important to know the difference. So this is for average velocity, and this is the definition and the formula. So guys, you see the unit conversion, please. You should be careful with the what? Unit conversion. So let's look at some of the most common units, isn't it? Unit conversion, because the units are not, unit conversion is not given on the formula sheet. That on the formula sheet you will get the formula, a list of the formulae that you need to be using. But then the unit conversion is something that you need to know in your head. So let's look at some of the most unit conversion, okay? We can start with speed and what? And velocity, okay? When you go from kilometer per hour, so let's say your speed was given in kilometers per hour, okay? And you want to take that thing to meters per second, okay? Meters per second. What do you do? And then what happens if you want to go the other way around? If you want to go from meters per second and you want to change into kilometers per hour, well, you do the opposite, isn't it, of what you've done. So from here to there and the other way around. What also happens if you want to go from kilometers to meters? Because see, these are some of the mistakes that cost people unnecessarily, okay? You should know the units. So now, if we go from kilometer to meters per second, okay? If you go from here to there, you must divide by what? By 3.6, okay? And then here you must multiply by 3.6. You see? So, e.g., an example. For example, okay? So, okay, let me do examples also. So if, say, for example, we have 72 kilometers per hour, you see, 72 kilometers per hour, and then we want to change it into meters per second, okay? So what do? We divide by 3.6. So it means we are going to do this, you see? Let me just move it here a bit. It means 72 kilometers per hour will be equal to 72 and then divide by 3.6. See? So this means that this thing is going to be 20 meters per second. So if you just divide by 3.6. And then say, for example, you have 10 meters per second. And then you want to change that into kilometers per hour. Okay. You just take the 10, you multiply it by 3.6. And then that's going to give you 36 kilometers per hour. And guys, please remember this. They are very important. So how do we go from kilometers to meters? We multiply by 1,000. From meters to kilometers, we divide by 1,000. Okay. Then, so e.g., example, So example, say we have 2 kilometers. 2 kilometers will be equal to, we multiply by 1,000. So it's going to be 2 multiplied by 1,000, which is going to be 2,000 meters. You see, if you multiply by 1,000, it changes into meters. Meters to kilometers. Say, for example, we have 500 meters, and we want to change that into kilometers. So it's going to be 500, then we divide. So we divide in this case. So it's going to be 500, and then divided by 1,000. So it's going to give you 0.5. 0.5 kilometers. So now, guys, these are not all the units, okay? So this is not all. Please, so understand me. This is just some of the most common units that you will come across, okay? I'm not saying it's all. It's not everything. There are still centimeters, there are still millimeters, and there are still all other things. But this is the most common. So it's up to you. The point I'm trying to make here is that the unit conversion is not on the formula sheet, and you should know it by the head. So what you will find on the formula sheet is the formula, you see. The formula for the average velocity and for the average speed, see, and many other. You will find a long list of the formula, but you can't find, you must know how to convert by yourself. It's not given on the formula sheet, see. So yes, guys, let's leave it here for lesson 1, okay? In the next lesson, we're going to bring an example, okay, whereby we use the formula here to calculate, okay? So thank you for tuning in. Thank you for tuning in again into Math Zone. I hope you tune in for lesson 2. So lesson 2, we're going to do an example, and we're going to use the formula there, the formula that I've introduced here, see. So bye-bye for now, and take care.